Hello and welcome back to Higher Maths Stationary Points, part of the differentiation topic. So another example on stationary points. Find the stationary points of y equals 4x cubed minus 2x to the power 4 and determine their nature. So first step, differentiate. So dy dx equals 12x squared minus 8x cubed. Step 2, set dy dx equals 0. Remember, we always need to make this statement. It's very important that we do. So 12x squared minus 8x cubed equals 0. So take out a common factor if possible. So this time we can get out not just 4, but 4x squared is a common factor. So 4x squared bracket 3 minus 2x equals 0. So if 4x squared equals 0, then x must equal 0. And 3 minus 2x, add 2x to both sides, divide through by 2, and we'll find x equals 3 over 2. Find the y coordinates to go with the x coordinates. So y of 0 will just be 0. If we substitute 0 into here, we're going to get 0. Find y of 3 over 2. So substitute 3 over 2 into the original equation, because if we want the y coordinate, we've got to substitute into y equals. So there's the working for it there. So cubing the fraction, so cubing the top and the bottom, the numerator and denominator, multiplying through by 4, looking for a common denominator if necessary, and then simplifying. So once we've done all of that, the nature table is the next step. So remember, with the nature table, we're looking at what is happening either side of the x coordinate. Okay, we know something's happening at 0. We know, scroll up to the picture again, we know either this, 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 or this is happening. So we know that the gradient 0 at our stationary points. So we need to look just before and just after to see what the gradient is doing. Okay, so if it's increasing, then decreasing, we've got a maximum. Decreasing, then increasing, we've got a minimum. If it's increasing, then increasing again, we've got a rising point of inflection. And decreasing again, we've got a falling point of inflection. Okay, so remember, when we differentiate, when we get dy dx, that is the gradient for any value of x. So here, dy dx is 4x squared bracket 3 minus 2x. So if I substitute in my 0, 4 times 0 squared multiplied by anything will be 0. So the slope at that point is horizontal. Now look before 0, so I'm going to pick negative 1. 4 times negative 1 squared is positive 4. 3 minus 2 multiplied by negative 1 is 3 add 2, which is 5. So I have 4 times 5, so I've got a positive multiplied by a positive, which is going to give a positive answer. So before x equals 0, the curve is increasing. So I've shown the slope here in the table. I've shown that the slope is going up. And then we need to look between 0 and 3/2. Well, 3/2 is 1.5, so I'm just going to pick 1. So 4 times 1 squared multiplied by 3 minus 2 times 1. So I've got a positive multiplied by a positive again, which is a positive. So after 0, the curve is increasing. Okay, so that is what is happening here. I've drawn that on there. So there's a rising point of inflection at 0, 0, so we must always make that statement. It's asked for in the question. We must make that statement. Right, let's look around 3 over 2. Well, we've already looked at what's happening when x is 1, so I can just use this part again. If we want to, we can substitute in again to double check. So 4 multiplied by 1 squared multiplied by 3 minus 2 multiplied by 1 is a positive times a positive, which is a positive. 3 over 2, when we substitute into the bracket, it will give 0. So we've got 4 multiplied by 3 over 2 squared multiplied by 0, which is 0. Gradient of 0 is the flat part here. And then anything after 3 over 2, so 3 over 2 is 1.5, so that's picked 2. So 3 minus 2 2's is a negative value, so I've got 4 multiplied by a positive multiplied by a negative, which is a negative. So it's rising, then it's flat, then it's falling, so that's a maximum turning point at 3 over 2, 27 over 8. Okay, right, if you've not quite picked up the nature table, watch the videos again. It's important.